Welcome to this A-level chemistry video on electrochemical cells. This is the second part of two. So far we've taken a basic view of cells and we've considered the simple cell configuration. Now I want to explain to you what electrochemical cell is in detail. Here we can see a diagram of an entire electrochemical cell, and you can actually see that this is separate. There are essentially two separate reactions taking place, and in each separate beaker we have what is called the half cell. So we have, if you like, the left half cell and the right half cell. I want to stick with the example we used earlier on of the magnesium copper electrochemical cell example. So here I have my magnesium metal, and to maintain colour convention, I'm just going to label and shade that black for magnesium. So magnesium solid. Now this magnesium metal, or my magnesium metal electrode, will be dipped into a solution of magnesium ions. So they will be Mg2+ aqueous ions. The solution might actually be something like magnesium sulphate. On the other side, in my other half cell, I have my copper, which I'm of course going to colour or shade in orange. Okay, so there's my copper metal electrode. Copper solid electrode, and of course it will be dipped into a solution of our copper sulphate, but for this bit we'll say it's dipped into a solution of copper ions, Cu2+ aqueous ions. And so we see that each half cell contains a metal dipped into a solution of its own ions. The only other thing I've not talked about is this bit here I'm shading in red, which is the salt bridge. Okay, and what this is it's a piece of, in this actual setup where we have two beakers with some salt solutions in them and some metals, we would actually take a piece of filter paper and roll it up and then bend it into a U shape, and we dip it into some potassium chloride or potassium nitrate, and then we'd hang it in a U shape so that the two ends of our bridge dip into either half cell. And the idea is that this salt bridge connects the circuit. The A-level course doesn't go into the chemical details of how the salt bridge works. At this stage, we're more interested in how a voltage occurs. So, going back to what we said when we looked at the simple cell, we said that magnesium is more reactive. Okay, well, let's now consider what happens. The magnesium and the magnesium ions exist in, well, the magnesium is more reactive, so it's going to want to release electrons. We sort of said that the electrons were going to move in this direction anyway. So what we can see is that the magnesium solid is somehow being converted into the magnesium ions and the two electrons. Well, actually this happens, each half cell sits as in a dynamic equilibrium. However, when we connect the magnesium half cell to the copper half cell, because the magnesium half cell is more reactive, what happens is the position of equilibrium sits further over to the magnesium ion side. So I'm going to use a sort of slightly different dynamic equilibrium symbol to show that the position of equilibrium sits further over onto the magnesium ion side. In the copper half cell, what happens is essentially the opposite. We know that the electrons will flow to the copper. The copper is the least reactive of itself and magnesium, so we know that it's going to accept electrons. So what is actually going to happen is the copper ions and the electrons, 2 electrons, will form the copper solid. Again, the copper ions and the copper solid are the half cell on its own is in equilibrium, but when we connect it to the magnesium half cell, when we connect the copper half cell to the magnesium half cell, the reaction shifts over towards the copper solid side more. So over time, what we would, as the electron flows through the electrochemical cell, as we record a voltage on our voltmeter, and we leave this running for a period of time, and electricity is being supplied to some circuits, we would expect to see that the magnesium electrode would wear away and the copper electrode would build up. Now, we can also talk about what's happening in the electrochemical cell as a redox reaction, because we can see that the magnesium is losing electrons. So the magnesium is being oxidized and the copper is being reduced. So we can see that since an oxidation and a reduction reaction are happening simultaneously, this is a redox reaction. Thanks for watching this video on electrochemical cells. If you'd like to know more about setting up and investigating electrochemical cells and measuring their voltages, please join us at kippersconsultancy.co.uk, where you can book a lesson and discuss your ideas with tutors. They will help you to pin down your knowledge at exactly the right level for your studies to help alleviate your doubts and improve your confidence.